Hi students, today we're going to learn about a very interesting topic, the characteristics of the particles of matter. You see, in the last chapter, we'd understood that matter is made up of particles. But then what are the properties of these particles? Are they far apart from each other or are they close together? Are they stationary or are they moving? We learn about exactly how these particles behave in the chapter Characteristics of Particles of Matter. Let's proceed. Matter particles in general have three very important characteristics that you have to remember. The first one is that the particles of matter have space between them. You can see this is a particle of matter and this is a particle of matter, and there is space between these two particles. Sometimes it may seem that the particles of matter in a solid don't have any space between them. Isn't it? After all, when you look at your keyboard or your computer or your table, you can see that the particles of matter definitely aren't spaced out. However, there is some space between the particles. That space is very less in case of solids, but it is still there. You can notice the space especially, in the case of air. Air particles have so much space between them that they can flow easily, from one place in the room to the other place in the room. Particles of matter are continuously moving. Here we go. They're not still, but they're continuously moving. Again, this might seem very weird, in case of solids, because you may say that the particles of solids are fixed, but they also vibrate about some position. So the point is that all particles of matter on this earth do keep moving always. You must remember that. The third important characteristic is that the particles of matter attract each other. This means that two particles of matter have some force between them which pulls them closer. When you pour water in a water bottle, the water stays in the water bottle, isn't it? The water does not come out of the water bottle and go off to some other room. That's because the water molecules attract each other. Understood? Let's learn in detail about all these three characteristics of matter. Let's look at the first characteristic first. Particles of matter have space between them. Here we go. Consider a beaker full of water. Now let me add some sugar to the water. What will happen? Clearly, the sugar will dissolve in the water. The reason is that initially there were only water particles, isn't it? Now, when we added sugar to the water, the sugar particles, these brown ones here, occupied the space between the water particles, and therefore they dissolved in water, isn't it? If water particles did not have any space between them, then sugar could not dissolve in water, isn't it? Because then sugar would have either floated above water or it would have sunk down below water, but it could never have gone inside the water. It went inside the water only because water particles had space between them, isn't it? And that tells us that the particles of matter, even the particles of water, have space between them. Did you understand that? So that proves the first characteristic of matter. We drink tea almost every day, and tea is possible only because the particles of matter have space between them. The tea leaves, some of them dissolve in the milk and in the water. The sugar that we put in the tea, it dissolves in the milk and the water we add to the tea. And all that happens only because water and milk particles have space between them. Similarly, lemon juice is possible only because particles of matter have space between them. In lemon juice, the juice of the lemon dissolves in the water, and it's able to dissolve in the water only because water molecules have spaces between them which are filled by lemon juice particles. Understood? That's how we're able to drink lemonade. So that was about the first characteristic of the particles of matter. Let's move on to the second important characteristic. Particles of matter are continuously moving. How can you actually prove that the particles of matter are continuously moving? Consider a room like this. It seems quite attractive, doesn't it? Now let us burn an incense stick, an agarbatti, here near this window. When we burn this incense stick near the window, what do we see? we see that the smell of the incense reaches us even if we are at the other end of the room, isn't it? You must have observed that. So, even if you're not standing near the window, but even if you're standing, say, very, very far from the incense stick, you can still smell the incense, isn't it? That happens because the particles of matter are continuously moving. So, the incense particles, they move from the window to the other end of the room in a very small amount of time. Understood? So, since they're continuously moving, randomly they move and they reach your nose even if you're far, far away from the incense stick. If on the other hand, particles of matter were not continuously moving, in that case, the smell of the incense would not have reached you if you were at the other end of the room. Isn't it? The very fact that you're able to smell that incense at the other end of the room is because the particles of the incense are continuously moving and they reach your nose. Let's consider another example. Let's take this beaker full of water and let's add a drop of ink to this water. What happens this time? Well, the ink spreads in the water and very soon all the water becomes green because of the green ink. So even though we added a drop of ink only in one portion of the water, that ink has spread throughout the water and turned the water into green water. This has happened only because the particles of matter are continuously moving, isn't it? So the particles of ink are also continuously moving and the particles of water are also continuously moving, and that is the reason the ink has been able to spread throughout the water, isn't it? Similarly, if you take a crystal of potassium permanganate and if you add it to water, what will happen? Very soon, all the water will be full of pink color and the water will turn pink. Now we added just a crystal of potassium permanganate, somewhere at one corner of the beaker, and suddenly the entire water has turned pink. This has happened only because matter particles move continuously. So the particles of potassium permanganate, they move continuously, and that is the reason they turn all parts of the water pink. So this tells us that the particles of matter are continuously moving. Now there's another small concept related to the motion of matter particles. This concept is called diffusion. You see, until now we were saying that the particles of matter are continuously moving, but in which direction do the particles of matter move? After all, do they move straight? Do they move to the left? Or do they move randomly anywhere? There is a certain direction in which the particles of matter move, and that direction is defined by diffusion. If molecules or particles of a substance are free to move, they move from their higher concentration to their lower concentration until the concentration becomes equal everywhere. This movement is known as diffusion. Did you understand that? You see, diffusion means that particles of matter move from the place where they are in a large amount, that is, they have a very large concentration, to the place where there are no particles of matter of that substance, where there is a very low concentration of particles of that substance. If you take a perfume bottle, for example, the perfume particles, they move from their area of higher concentration, which is near the perfume bottle, to their area of lower concentration, which is far away from the perfume bottle. That's because near the perfume bottle there are a lot of perfume particles, but far away from the perfume bottle there are zero perfume particles, isn't it? So the perfume particles move from their area of higher concentration, which is near the perfume bottle, to their area of lower concentration, that is far away from the perfume bottle, until the concentration is the same throughout. Understood? And this is called diffusion. This is a very, very important concept related to the direction of motion of matter particles. Consider, the same example that we considered some time ago, the drop of ink. Now, when the ink drop falls into the water, it moves from its region of higher concentration, that is the exact area at which the ink drop fell on the water, to its region of lower concentration, which is the rest of the water where there is no ink initially. So the ink moves from the place where there is a lot of ink to the place where there is very, very less ink. Understood? And that is why the whole of the water turns green. Similarly, in case of a potassium permanganate crystal, the potassium permanganate crystal moves from its area of higher concentration, that is a place near the potassium permanganate crystal, to the rest of the water which does not have potassium permanganate. So the particles of potassium permanganate move from their area of higher concentration to their area of lower concentration. So that is about the diffusion of matter particles. There is, however, one interesting fact that you must keep in mind here. The particles of matter in general move randomly. If you look at the air around you, the air particles are moving randomly. However, in the special case, when there is a higher concentration of particles somewhere and a lower concentration of particles somewhere, then apart from the random motion, there is also an overall net motion from the region of higher concentration to the region of lower concentration, and this net motion is called diffusion. Understood? But once diffusion has taken place, once the particles of matter have moved from their region of higher concentration to their region of lower concentration and spread uniformly, the motion of the particles again becomes random. Understood? So in general the motion of particles is random, but when there is a higher concentration somewhere, then overall, apart from the random motion, the particles move towards the lower concentration region. So that was about the motion of particles. The third property of matter was that the particles of matter attract each other. Now, how do we prove that the particles of matter attract each other? Simple. Take a look at these pieces of chalk here. This green chalk, blue chalk, yellow, orange and violet chalk. All of these chalk particles are rigid. They have a fixed shape, isn't it? A chalk looks like a chalk, and that's that. The chalk particles do not disperse into space, and spread everywhere on this earth. They are there in the form of a fixed and rigid chalk. This happens only because of the force of attraction between the chalk particles, and this tells us that the particles of chalk, or in general the particles of matter, attract each other. Take a look at these nails. These nails have such a fixed shape. As you can see, they are pointed at one end. There's this round part of the nail at the other end. Similarly, this glass, it's also fixed. It has a rigid shape which cannot easily be changed, isn't it? This glass has this shape no matter what, and this is possible only because the particles of glass and the particles of these nails, they attract each other, isn't it? Even water particles attract each other. Consider, this water which is flowing from the tap. You can see that the water flows in a straight line, isn't it? It feels like it's almost a rope of water, a rod of water, isn't it, which is coming out of this tap. That happens because the water particles attract each other. If the water particles did not attract each other, in that case, water particles would simply come out of the tap and move wherever they wanted to move, isn't it? They wouldn't stick to each other as they were flowing down from the tap. They are sticking to each other as they are flowing down from the tap only because there is force of attraction between the water particles. So here we go. Water particles attract each other, chalk particles attract each other, and nail or iron particles also attract each other. However, you must notice one thing here. The force of attraction between particles differs from substance to substance. As you can see, the force of attraction is very less in liquids. For example, the force of attraction in water particles is less than the force of attraction in chalk particles. When you put your hand underneath this flow of water, immediately, you can stop this flow of water, isn't it? You can break this chain of water particles by simply putting your hand under the tap. On the other hand, you can put your hand over the chalk, but definitely the force of attraction between the chalk particles is so strong that the chalk won't break, unlike the water cylinder which just broke when you put your hand under the tap. However, when you break the chalk with your hands, the chalk breaks, isn't it? So that means that the force of attraction between chalk particles is strong, but not very, very strong. Because if it was very, very strong, then the chalk shouldn't break, even when you're trying to break the chalk with your hands. Iron has particles which really attract each other a lot. That is because you cannot break those nails with your hands, isn't it? You can try and try, but no matter how hard you try, the nail will still be a nail. In fact, maybe it won't even bend. On the other hand, the chalk breaks, and the water layer simply can be broken by putting a hand underneath the water. So this tells us that the force of attraction in water particles is less than that of chalk particles, which is less than that of nail particles. So the force of attraction is different for different substances. So that was about the force of attraction between matter particles. Until now, we were studying about the properties of matter particles. Like the fact that they're continuously moving, the fact that they move from their region of higher concentration to their region of lower concentration, the fact that they have spaces between them. Now we will study an important concept. What happens when heat is provided to matter particles? Let's say you have this box which contains air particles. Now clearly the air particles are moving like this. After all, they are continuously moving, they are attracted to each other, they have space between them. What happens when you heat this container of air? Let's find out. When some heat is provided to these air particles, they start moving faster, like this. The space between the particles increases, because when the particles start moving faster, they keep on moving more and more away from each other. The kinetic energy increases. After all, the particles start moving faster. And the force of attraction between the particles decreases. This is because, again, since the particles are moving faster, they can very easily move far apart from each other. And when they move far apart, the force of attraction decreases. So this is what happens when heat is added to air particles or any matter particles. What happens if more heat is added? In this case again, the particles start moving even faster. The space between the particles further increases. The kinetic energy further increases. The force of attraction decreases because the particles, now become very individualistic. Like their motion is now only governed by their energy, and the influence of the energy of other particles decreases considerably. Understood? The particles move really fast when heat is provided. When you further increase the temperature and provide even more heat, the particles move very, very fast indeed. The space between the particles increases even further. The kinetic energy increases even further. And the force of attraction becomes almost negligible as the particles move very, very far away from each other. So this is what happens when you increase the temperature of matter particles, or when you basically add heat to the matter particles. Heat is basically a form of energy, isn't it? This energy gets transferred to the particles and increases the kinetic energy of the particles. Understood? And as you can see, the increase in kinetic energy leads to faster particle motion, decrease in the force of attraction between particles, and increase in the space between particles. You can basically say that on heating, the space between the particles increases, the kinetic energy increases, the force of attraction decreases. Overall, the freedom of movement increases because now the particles have greater energy and they can move wherever they want. Understood? Exactly the opposite effect occurs when we cool matter particles. When we take away heat energy from matter particles, or when we cool them, the space between the particles decreases. They start moving slower. That's because we're taking away some energy from each particle, and therefore the particle is slowing down because its kinetic energy is decreasing. So on cooling, the particles come closer. The space between the particles decreases. The kinetic energy decreases as the particles slow down. The force of attraction increases because as the particles come closer, they are attracted more and more towards each other. The freedom of movement of particles decreases because as they are attracted more by other particles, they are not as free, to move around and do what they want. So this is exactly what happens to particles of matter when we heat them or when we cool them. You must remember all these properties. Now that we've studied so much about matter particles, their properties, their characteristics, what happens on heating, what happens on cooling, diffusion, let's try to solve some small problems related to particle motion. Why does the smell of hot sizzling food reach you several meters away, but not the smell of cold food? Well, can you think of the answer? The correct answer is that when food is really hot, in that case, the particles of matter have a lot of kinetic energy. The particles coming out of the food, the gases, the vapors, they have a very high kinetic energy, isn't it? Because after all, the food is hot, and therefore they easily reach our nose. Even if we are far away, the particles move fast and they are free to move. They have very high freedom of movement. and that's why they reach us very easily because of their high kinetic energy. When food is cold, however, the particles move very very slowly. They have very less kinetic energy and they're hardly free to move. So the particles, of the vapors that come out of the food, they are not able to reach our nose because they don't move fast enough. They don't have that freedom to move away. They move in a very small region of space, and that is the reason that cold food almost doesn't smell unless you go very very near it. Understood? That's the reason hot food can be smelled even when you're a very long distance away, and cold food is very difficult to smell even when you are near that food. At higher temperatures, the kinetic energy and freedom of movement of particles is more, and that is why the food vapors can easily move and reach your nose when the food is hot. Here's another question. An iron rod is very difficult to bend, but when it is heated to very high temperatures, it is possible to bend it quite easily. Why is this so? Again, can you tell the answer? Well, the answer is quite simple. At lower temperatures, the force of attraction between iron particles is very high. So no matter how hard you try to bend the iron rod, you cannot move the particles of iron away from each other. You have to try really really hard and still you're not able to move the particles of iron away from each other. On the other hand, when iron is very very hot, in that case it's very easy to move the particles of iron away from each other. It's very easy to bend the iron rod, isn't it? Because at high temperatures, the force of attraction between particles decreases because their kinetic energy increases, their freedom increases, and they want to move away from each other. So since the force of attraction decreases at high temperatures, it's very easy to bend a iron rod at very high temperatures. That's our answer. So there you go. This chapter was about the characteristics of the particles of matter. Hope you understood them. Let's now move on to the next chapter.